Welcome to the Packaging Etc. podcast, where we will discuss all things packaging and some things not. We will hear from professionals across all areas of the industry: design, engineering, manufacturing, and many more. We will learn about packaging trends, new technologies, and cutting-edge innovations. This podcast is all about showcasing our favorite parts of the industry, the people, and giving them a platform to share their stories and their knowledge of packaging. Let's take this journey together. And now, your host, Matt Mulvey.
Hi, folks. Welcome back to another episode of the Packaging Etc. podcast. This week, my special guest is a former professor of mine from Rutgers, PhD in material science from Rutgers University, Dr. Tom Nosker. Tom, welcome to the show.
Hi, thank you, Matt. Very nice to see you again. Well, sort of, but I always enjoy having you as a student. You're a very good student.
Listen, you already gave me my grade. I don't think you need to have. There's no need to blow smoke.
Okay, cool. No smoke involved.
Yeah,
actually.
Yeah. Do me a favor, just kind of, for the listeners, just introduce yourself. Tell us a little bit about who you are and where you've come from.
Where I come from, who I am. Okay, so I grew up in Georgia, and I went all the way through school, including college. I went to Georgia Tech. My parents had a place that was 10 miles from Georgia Tech, so that was the local engineering school. And I actually kind of, college wasn't my first choice, but it became my first choice. I worked at a car dealership. Many Southern boys know how to work on cars almost instinctively. And I was one of those. And I worked for the biggest Volkswagen dealer in Atlanta, and I found, they had maybe 50 mechanics about, but none of them were age 50. They all were complaining about physical problems and stuff, and in their 40s. And I figured that was not a good long-term thing for people who generally, I was told in high school, lived to their early 70s. I could not figure out what you would do to earn a living in your last 20 or 30 years. So I went to engineering school, and I actually had an advantage, I think, over most of the engineering students, because I already knew a lot about machines, and I really liked my classes in material science. They just seemed to make sense to me, almost before I read much about them. And so I went to graduate school at Rutgers in material science, and I saw that the biggest growth area among all materials was in plastics. I mean, plastics basically grow. They've been growing for the last 50 years or so, maybe 10% a year on average. That's mostly replacing metals and ceramics in many different applications. And so that seemed to be a smart thing to do, is to get involved with something that was growing rather than something that's getting smaller in terms of market. So I got my degree, and I was, shortly after I got my PhD, I was offered to stay at Rutgers, partly because of my interest in research and success at research, and partly because I had already taught some classes as a grad student, and I was seemed that my students were happy with what kind of job I did. So anyway, that's what got me started in my career. And it's actually, I'm near the end of it. I mean, I'm beyond normal retirement years. I'm very happy. I had a lot of fun, and I got to work on what I wanted to work on, which is unusual. Most people get told what to work on unless they own their own company. And it's been pretty good for a lot of people. I've created a lot of jobs and stuff too. So yeah, it's been fun. I took advantage of the fact that I know machines. I joke a little bit, but it's true that machines are easier to understand than people. People are complex.
Yeah.
And
I can get on board with that.
So basically, I've developed or made changes to lots of machines through the year. I got involved with packaging engineering. I taught packaging engineering classes at Rutgers for 8 years. My teaching load was getting heavier and heavier, but meanwhile, it was easy for me to raise money and have graduate students work on projects. The people that were loading me with classes seemed unrelenting. So eventually I just decided to just do research pretty much. I mean, I still taught some classes, but.
So yeah, I didn't realize that you only taught for 8 years. And I was lucky enough to be at Rutgers doing my undergrad during that time. So, that's how you and I came to know each other. And
right.
I do speak fondly of that class. And again, I you're not going to improve my grade. So, blowing smoke may be pointless, but it was one of the most memorable classes that I had at Rutgers in the packaging program because I was the only student. And if I recall, I think Rutgers and maybe other schools as well have a requirement where if there are less than 3 students in the class, it's at the professor's discretion whether or not he or she would teach the class. And you came to me and said, you need this class to graduate. And I said, yes, sir, I do. And you said, well, listen, I'm willing to teach it if you're willing to take it. And I said, absolutely. So it was just you and I for the entire semester in the old Army barracks on Bush campus. And just a very memorable experience for me taking that class.
Thank you. Yeah, I always loved teaching, but the management at Rutgers, loaded me with more and more classes and different ones. And I would tell them, I'll be honest with you, I would just go to them and say, hey, I've got an idea for a new class I think that could really, really help the fundamental understanding of the packaging students. And I'm willing to teach it. And so then they would add that to my list of classes that I was going to teach. And so there was more work, but, that was going to take time out from my research. And I had graduate students at that point and that I was trying to support and had to keep sponsors happy and stuff. And yeah, I could see that there was never a class that I started that they let me off of. That's the problem.
Yeah.
And so I tried to get that to happen, but it didn't work. And so then I said, I think I'm just going to do my research because I'm actually very good at that too.
Well, and so it sounds.
But I love teaching. I mean, it's always fun to talk to students and to try and I always treated everybody as though they were more or less my equal and allowed them to ask questions and stuff. I never, and there's no stupid question. There's only stupid answers. It was a great experience on all sides, I think. But anyway, yeah. So I ended up, raising many millions of dollars in R&D and having, nearly 100 patents.
That's
on a variety
amazing.
of things.
Absolutely amazing. So, well-deserved honors. So speaking of honors, I know you were featured in an article recently, and in my first episode of the podcast, when my wife interviewed me, I absolutely fumbled the mention of you because I didn't have specific notes, and so I didn't get the verbiage just right. But I understand that you were nominated into the National Academy of Inventors. So, give us a little background on that. Where did that come from?
So I'm actually already in the National Academy of Inventors, but I'm going to become a fellow of the National Academy of Inventors. Okay. And fellow has special meaning to academics, especially. In my early career, I really focused on plastic recycling. And
that's where the Rutgers packaging program kind of got its start, right? Was through recycling?
No, it got its start as a packaging program before anybody was plastic recycling. And then about 1985, basically people were, okay, the long history is, I'll try and do it very quickly. World War II, when it came about, we wanted to win the war, and we went through a lot of special effort to try and win World War II. In order to do that, we had to target the materials that the military needed to win the war to them. And so there were a lot of things that the public stopped being able to get. There were no, for example, for kids' bicycles and for wagons that they would pull along and stuff like that, there was no more steel ball bearings available for the wheels.
Yeah, all
and
those
so they had to figure out how they were going to.
Yeah.
Right. That's right. So, and that went on for lots of materials and a lot of different ways. And people, as part of that, they recycled, paper and metals and glass. And there was no plastics used for very much of anything during World War II. Meanwhile, plastic, being developed, continually being developed, made in those days from oil, found uses as plastic bags. They started to take over, glass bottles first in the bathrooms, because, of course, to have a glass bottle fall on a bathroom floor where you got no shoes on, it can be a bloody mess. No pun. So, anyway, they gradually took over more and more applications, and nobody had ever tried to figure out how to recycle them. And that was becoming a big issue. And people were saying, we should ban these. We should go back to the old materials. And that was going to cost more money to do, and it would be less efficient. Plastics are lightweight. They're, low temperature to process typically. I mean, compared to glass and metals. And, they make sense in a lot of ways. They actually do make sense. I mean, I know there's been people talking about a lot of microplastics in our body and stuff like that. And that's really doesn't get any traction among scientists, because all they're doing is finding out that there are a lot of hydrocarbons in our bodies. Well, we're a hydrocarbon-based species, as are lots of other animals. I mean, all other animals, really. You're going to find hydrocarbons that look like the plastics in our bodies and outside our bodies. But that doesn't mean that the plastics can easily be ingested by us and find itself, in our brain or anything like that. In fact, there's a lot of things that can't make it through the blood-brain barrier. A lot of small moleculed animals and things can't. So there's no germs, in our cranial fluid, which is clear normally. If you break your blood-brain barrier, you can die. And that actually happened once to me during a botched operation. Anyway, I know about that. And wow. People are finding small hydrocarbon molecules in people's bodies, but they belong there, actually. And they didn't come from plastic that degraded somehow. So anyway, that's a discussion. I'd be happy to have that discussion technically with anybody. Reading the papers that talk about nanoparticles of plastic. So that's what they call it. They say they're nanoparticles of plastic, and they look similar. That's because we are a hydrocarbon-based species, and those are made from hydrocarbons, and we just make them into very big molecules.
That makes sense. Okay. Wow, we took a long detour there.
Pardon?
So we took a little bit of a detour there.
Yeah, I did. I know.
That's okay. That's okay.
I don't know. Yeah. But anyway, it's relevant, and there are constantly people, that I think, and sometimes they're well grounded, that we needed to figure out how to recycle plastics. So there's resin recovery processes. Rutgers began licensing in 1987 a resin recovery process that could be used for PET bottles, soda bottles, and nowadays water bottles. People weren't selling water in plastic bottles back in those days, right. But in the 90s that started.
So it's interesting. You made reference to World War II as kind of being an impetus towards the recycling program, modern day recycling initiatives. I want to say the genesis of the product Nutella was also born out of a similar necessity. So it was a baker in Italy during World War II. The Italians were rationing chocolate, and the baker was not able to get his hands on enough chocolate to make his product. And so he supplanted some of his chocolate with hazelnut, and people fell in love with the flavor, and boom, there's Nutella. And so the Nutella product was actually born out of World War II rationing.
Wow. Necessity is the mother of invention.
Yeah, absolutely.
That's how that really works. Yeah, so nobody had ever looked at plastic recycling until it became so popular that was the one material that should be recycled that wasn't being recycled, and so people had to focus on it. And then plastic lumber. I was the lead guy behind all the plastic lumber stuff, and then we gradually got around to figuring out how to turn high density polyethylene based plastic lumber into a structural material, and then eventually build bridges, including, tank bridges, railway bridges, and road bridges, and then railway ties, which are normally made out of oak, which has got very good mechanical properties. And
it has very good mechanical properties. But my understanding is with our lumber harvesting processes these days, there's the slow growth, old growth forest versus the fast, grow it to harvest it type lumber, and your structural properties between the two are vastly different. So when they say they're not making them like they used to, that is a specific example of that. Is that correct?
Well, so the stuff so there's also different kinds of trees, right?
Right.
So, a 2x4 to be used in a house for a joist or something like that, or for a wall, might be pine. Mm-hmm. And pine does not have anywhere near the mechanical properties of something that's a hardwood like oak. So the railway industry only makes bridges and railway ties out of oak. And those aren't farmed because they take 100 years to grow. Mm-hmm. But pine trees are routinely grown like corn. And several acres will get mowed down and turned into paper and combination of paper and pine boards for houses. The old growth forests are where the oak trees are, and they tend not to be that straight. Mm-hmm. Some of the pine trees, southern yellow pine, for example, are straight and long, and you can make telephone poles are made out of that too. Not that strong, not that stiff, but straight and good enough mechanical property. And then they, of course, have to if they want to put it outside and not have it deteriorate in like 3 years, they have to put poisons in it, mm-hmm. so that the bugs that try and eat them die. And so for railway ties, it's creosote, a black tar. Chromated copper arsenate is still used for most pine applications. But also creosote is used for some telephone pole type applications still.
Okay.
But those are all not pleasant for people to work with, and it can kill them.
And so the plastic recycling technology that you've developed over the years that has led into this AMIP program? And I'm not going to remember the exact acronym, but I know there's miscible and immiscible polymer blends in there somewhere from our class. But that was all born out of plastic recycling technology, correct? So kind of walk us through kind of where that's at. And I know that you're making structural lumber, but I would love to understand what type of packaging applications there could be, not just as a raw material stream for the recycling, but turning it around and then making packaging components potentially out of that material.
So I don't know that you're going to use a standard replace, a standard packaging material with that stuff. Generally, we figured out how to put like glass fibers in it and orient them, even from things like car bumpers. So they're discontinuous glass fibers, and give properties that are good enough that they can be used for things like railway ties, and you can use them for pallets, though, I think, which is a kind of a packaging application, or at least package distribution kind of a material. But I think that the more recent stuff that we've been working with is not necessarily, although it's possible to do it with recycled material. We've been making graphene plastic composites and combining graphene and a little bit of carbon fiber and stuff. We can get the properties up so high that it's actually competitive with aircraft aluminum on a stiffness and strength and toughness per unit weight basis.
Okay.
And
I guess technically an airplane is a package. I mean, if you really want to go by the old
there we go. That's a
right?
reusable package.
That's a reusable package. There you go. There you go. There's our hook.
But we also, so the graphene it has potential for some packaging applications where gas permeation is an issue. So the graphene, so we have a process where we take graphite, which is very common, and it's mineable all over the world. There are places that have got maybe 30% of the soil is graphite. And of course, that's what's used in pencils, right?
Mm-hmm.
And people write with pencils. And so it's also used as a lock lubricant. So there are layers of covalently bound carbon that where each layer is very stiff and strong. It's actually stiffer and stronger than diamond in that layer, within the layer. But the layers themselves are very easy to shear relative to one another. And that's why a 5-year-old can write with a pencil. That's also how the lock lubricant thing works, is the layers can be sheared relative to one another without very high shear stress.
I never thought about it like that.
What we do is we take graphite and we put it in molten plastic, and we have it go through a process where we have alternating high and low shear on the slurry of material that we made. And we can separate the layers of graphene from one another. And we can also get really good bonding between the polymer and the graphene, which normally you can't do with like carbon fiber or anything, okay, or glass fiber and a plastic. But we can get covalent bonding between the graphene and the plastic, and we get way better properties than you might think. So the other thing is that each layer of graphene is impermeable to just about any gas.
Okay. Well, you got barrier properties now. Okay.
We can orient them so that they are in the plane of the plastic, so if you make a bottle, they'll be in the plane of the plastic that got blow molded. And that can affect the permeation rate significantly. And so we could make a thin but relatively impermeable, bottle for for a variety of drugs or for sodas or whatever out of this, and usually on a per pound basis, there's no plastic that's cheaper than graphite. The downside is that it makes a black bottle.
Okay, so yeah, we just backed our way out of probably 90% of the world's markets. But theoretically,
not necessarily. I mean, after all, do they not sell soda in cans and clear bottles?
Yeah, that's true.
So I'm not sure. Yeah, you may have completely blocked out some customers, but I think if they're open-minded, they might reconsider it.
Well, with the different levels of technology around decorating, I don't know what kind of a smooth surface, comparatively speaking, for printing directly on, even on a black surface, but putting a 360-degree label around a bottle or a shrink sleeve or something like that. I would assume from an adhesion perspective, those would be options as well. From a decorating, but
sure.
At the end of the day, it's still a black bottle.
It doesn't have to be black, but yeah, you can make it any other dark color easily.
Okay.
You just can't make it clear again.
Yeah. Yet.
Yeah. Yeah. Right.
I'm a glass half full kind of guy.
So I think there's still a lot. There's a lot to be done in all these things. But we can also get extremely good properties at a lightweight and low cost, and probably take over a lot of thermoset plastic composite applications.
Now,
with thermoplastic with graphene in it.
From an equipment compatibility perspective, would these materials require new types of machinery for processing,
no.
or it runs on existing technology?
No, it'll run. It requires special machines to make the composite, right? To have the high low shear alternating and get the exfoliation to happen. But once you've made it, you can run it through extruder or a injection molding machine or what have you, and you can blow mold things, whatever you want to do. Okay. So that you can do with plastic, you can do with that.
So there's a lot of
possibilities. You may be limited by how much graphene you have in on a percentage basis, because it won't stretch as easily.
Okay.
But you can. But if you put a low loading in, you might actually significantly influence the permeation and be able to get good elongation when you produce your at lower loading, at a lower loading. At a higher loading, you can compete with any loading that you can make with carbon fiber and thermosets.
Okay. Tell you, it's some interesting stuff. It'd be be really exciting to see, who grabs onto this type of technology and this material first for a traditional.
This is why I'm still here.
Yeah,
I'm beyond the normal retirement age right now, and I want to get to the point where it's running on its own. The railway tie stuff. The people that are licensing that, they're doubling in size every year.
That's great.
$88 million in sales last year.
So
44 the year before.
And I understand that how many continents are you on now with that plastic lumber?
I'm not on anything. Okay, I'm just an inventor.
Fair enough.
And Rutgers owns the patents.
Okay.
But the company that's licensing that, at one point there were two companies, one in America and one in the UK, that split up the whole world with this kind of technology, with the plastic lumber technology, okay, structural plastic lumber. And the Americans got in a fight with Rutgers. They didn't want to pay any more royalties to Rutgers. And so Rutgers took the license back from them. And they went out of business. The people in the UK that had the license for Europe. And other places. They kept it, and they eventually, after everything settled with the American company, they went to Rutgers and said, we would like to get the whole world now. Otherwise, America is not going to have this stuff easily or quickly.
Yeah.
And Rutgers said, yeah, sure, why not? You already know how to make it, and blah blah. And so they built a factory in Kansas somewhere.
Okay.
And now they're building, I think, 4 new factories in other countries, all other countries.
Yeah.
So they got one in the UK, they got one in Kansas, and they're going to Eastern Europe and to Australia and stuff like that. So
well, yeah, I mean, it would make sense from a distribution perspective, taking advantage of the local, raw material stream.
Everybody's all manufacturers for everything. That's all eventually going to come, because the U.S. is going to stop policing the oceans for everybody's, shipping worldwide and protecting everything, even when the United States isn't involved. They've done that since World War II, but that's ending. They've already begun to make changes to the military to make it so that will end. And so everybody knows it's going to end.
Yeah, well, and that's going to have a huge impact on global commerce. So yeah, I guess to your point, this UK-based company having, I guess we could call it exclusive rights to that technology, building facilities, regionally throughout the globe, kind of takes the impetus away from having to protect those shipping channels, right? They wouldn't really be subject to those types of issues because they have complete control over their specific regions. So yeah, it makes a lot of sense.
The other big change that's happened already with plastics is that that we are now, we've now got like close to 1,000 years supply of natural gas in the United States. And everything you can make from oil, you can make from natural gas, but you can't ship natural gas that easily, everywhere. And so we switched from making all the plastics from oil to natural gas. And the price of the natural gas is extremely low. So we've got basically the cheapest way to make plastics. But the plastics can be sent everywhere. But that's a huge change in the plastics industry. That's a direct result of Thomas Gold's. First, he wrote a paper that was in a major publication called The Deep Hot Biosphere, and then he wrote a book with the same title. And he predicted that there's actually natural gas underneath everybody's property, everywhere, the oceans, all the land, and it's not coming from dead plants and animals. And so, I don't know, around 2007, 2008, his book came out, which explained what his paper had alluded to, but with way more detail. And you can buy that book, by the way, for like $32 or something on Amazon.
Okay. The
Deep Hot Biosphere. And anyway, so once people who know how to drill wells read that, they recognized that in the United States, on anybody who had, let's say, a 40-acre farm or more, they could get the rights. If they could get the rights to drill on that property, and that property happened to have a natural gas pipeline, they could get paid to pump the natural gas into the pipeline. They don't have to buy tanks. They don't have to buy trucks. They don't have to buy anything.
Yeah, there's no distribution. Yeah.
And so that's what happened. We went from a 30-year supply of natural gas to a 1,000-year supply. in a very short amount of time. And most people focused on fracking, which is a method that's being used. Not everybody did it, in the safest way, but you can do it in a safe way, and where you don't, damage the land and everything, and get a lot of, and 95% of the wells that were drilled hit, kind of bearing and, making the point that it's actually under everybody's land. There's a natural process that occurs in the Earth's core that generates methane.
Mm-hmm. That's interesting. So yeah, I guess, if, knowing that there's that type of supply, and knowing there's a demand, I mean, obviously in the packaging industry, and I'm sure in other industries as well, there's the whole, everybody talks about sustainability and trying to get away from the traditional petrochemical based plastic materials and getting to bioengineered solutions.
But that's also how petrochemicals are made.
Mm-hmm.
It's made from the same process. It's just that if you have two methane molecules in the presence of iron at a little bit elevated pressure, it can grow into a longer chain hydrocarbon, which is like oil and thick, heavier. I mean, the molecular weight could be all over the map, right?
Yeah.
It could be very thick oil. It could be light oil, but basically that's not coming from dead plants and animals.
You mean it's not all coming from the dinosaurs?
It's not coming from it's not, a little bit came from the dinosaurs, but a huge amount is being generated every day. I know this is a new idea. It also kind of makes all the arguments, about the greenhouse gases and us, breathing out the gases that we generate by living. That's just complete baloney, really. All the civil engineers are being taught, Thomas Gold stuff. Not civil. All the chemical engineers are being taught the origin of oil and natural gas, and in that chapter, Thomas Gold's work is featured.
I'm gonna have to check that out. It's a book.
Yeah,
I'm assuming
everybody ought to know
on Amazon,
about it.
And
it's not getting a lot of press.
Yeah,
but I looked into it because, of course, I'm a plastic guy, and if the end of plastics is coming, I want to know about it.
Yeah.
I looked into it, so I started teaching about that too in some of my classes.
Mm-hmm. So you've mentioned a couple times so far that you're already past the normal retirement age. So assuming the stars align and you're able to retire in the not so distant future, what plans do you have? Bucket list type stuff. What's on the horizon?
I've got a granddaughter. I'm hoping I'm going to have more grandchildren.
Mm-hmm. Congratulations for that, by the way.
And I have some money and stuff, so I can teach them things and spoil them a little.
Spoil the hell out of them, absolutely.
Yeah,
I'm looking forward to the same thing.
Yeah, life is good, and I mean, and not that I don't like my job. I love my job, but the commute has gotten longer and longer for me. Not that I've moved, but that there are more people in between where I live and where I work.
Yeah.
Every year.
Well, I think that's the case pretty much anywhere in New Jersey that you live. The commute's not getting better; it's only getting worse.
Yeah, that's right.
So all right.
There are several companies that are licensing technologies. I develop fire retardant coatings and paint recycling technology, and blah blah blah. And I'm happy to help my licensees with issues, and there are times they will need my help, and I'm happy to help train the people that are going to be alive a lot longer than I will be, so they can deal with that kind of stuff. And I'm grateful. I mean, at one point, Rutgers estimated that just the plastic recycling stuff that we did alone was accountable for 1 million jobs in the United States.
1 million. Wow. Okay, that's a number.
Directly and indirectly. Well, you think about it. I mean, every city has got recycling technology. People separate the plastics from the metals, et cetera, and you start adding it up.
Yeah. I guess
which
I
somebody
never
did.
thought about it like that.
Those are all new jobs. Those are jobs that didn't used to exist.
That's
great. I'm very grateful. God gave me a lot of opportunity, and I seized some of it.
Well, your work has given a lot of other people opportunity. So, I guess pay it forward, pay it backward. But I guess on behalf of all of them, thank you.
Thank you.
I do have, I'm going to put you on the spot here. So you did your undergrad at Georgia Tech. You did your grad work at Rutgers. So Scarlet Knights or Yellow Jackets? I mean, you know what? Never mind. Don't answer that. It's okay.
I don't. I go to all the home football games at Rutgers.
Mm-hmm.
I went to all the home football games at Georgia Tech when I was there. It's an interesting sport. I was a little dissuaded with some of the games this year that looked like maybe the officials got more involved than they would normally be in the outcome of the game. I've not seen that consistently with any college games.
Yeah.
One of my sons goes to the games with me every time, and it's a lot of fun, and it's good, clean fun.
So
my granddaughter has got a bunch of Rutgers uniforms, she wears, and she could be who knows? Yeah, I don't know. Hopefully I would like her to go to Rutgers, but her parents might have other higher ideas, but I'm perfectly okay. I mean, Georgia Tech's a public university, and so is Rutgers. So I think Rutgers is a good school among the tiers of public universities. Georgia Tech and Rutgers are up there.
Yeah,
they're not at the bottom. They're not in the middle.
Well, listen, I'll be honest. When I was in high school and I was looking at colleges, I was like every other kid growing up in New Jersey. Right, Rutgers was my fallback plan. That was hey, here's my top 5. Rutgers is number 5, and I didn't realize just how widely regarded Rutgers as an institution of higher learning was until I got there and I started speaking to people that were from out of state and people that lived on my floor freshman year in the dorm that were from other countries, and when they started explaining to me, and because it's the local school, I grew up 45 minutes away, and so it was I know I took it for granted, but now looking back on it now, I kind of laugh at myself because you say, hey, I have an engineering degree from Rutgers. I take a lot of pride in that. So. But yeah, I guess a rough day for you would be when Rutgers football is playing Georgia Tech football. Who are you rooting for in that game? That's a tough one, right? Or are you going to be like Donna Kelsey wearing half and half?
That's a contrived situation. It hasn't happened yet.
Hasn't happened yet.
But
if the NCAA is listening, you never know.
It might depend on the players and stuff at that point. The details will be important.
Yeah. All right. Fair enough.
But I hope both teams would do well. And it would be a well-fought game.
Yeah. So basically, you're not willing to answer that. I got it.
That's the most you can hope for. No. I'm always interested in a good game. I don't like one-sided games.
I hear you. Well, listen, Tom, we're about up on our time here. So again, I just wanted to say thank you so much for joining us today and sharing with us some of your experiences and what you're working on. And hopefully in the not so distant future, we're reading some additional articles about, huge advancements in the packaging industry and your name plastered all over it. You never know. We'll see. Okay, great. Thank you very much, Matt. I really appreciate the opportunity to talk. Yeah, no, thank you. And we need to go have a beer sometime. Sold. Okay. We'll talk. Thank you, sir. All right. Take care. Thanks. Bye-bye.
Thank you for listening to this episode of the Packaging Etc. podcast. We hope you enjoyed the content and maybe learned something new. If you have ideas for future guests or topics, we'd love to hear from you. Feel free to send a connection request on LinkedIn or visit www.precisionengsolutions.com and use the contact form. Once again, thanks for tuning in, and we hope you'll join us once more on the next episode of the Packaging Etc. podcast. Until then,